Well, hello there. How's everybody doing? I'm sorry you hear my papers flipping. Welcome to Flippin' Carnegie Style with Mr. Frazier, and we are going to do lesson 2-4. Hopefully you are fired up and ready to go. We can get this done. You can have the notes, and then you can work on your skill practice. All right, so lesson 2-4. Lesson 2-4 is an extension of what we did in 2-3, which was less than, greater than, less than or equal to, or greater than or equal to. Okay, and it dealt with simple inequalities and solving of inequalities. And then the one rule we learned is that when you multiply or divide by a negative, finish it. Correct. Whenever you multiply or divide by a negative, you flip the inequality sign. Okay? So in this section, we will talk about a few words, one of them being a compound inequality. Okay. The next one being the solution for a compound inequality. Okay, and then as we keep going, we will talk about two other vocab words, one being the word conjunction, and the other word being disjunction. Oh, I just spelled that all wrong. I'm sorry. Conjunction and disjunction. All right, so here we go. When we have inequalities, we use inequalities to find multiple answers, right? We did that in 2-3. It means we're looking for multiple correct answers. And when we combine two simple inequalities, that means you have two simple inequalities and you combine them, you have what we call a compound inequality. So when we put two simple inequalities together,
Ms. Hernan and Ms. Boylan, can you please meet me in the guidance office? Ms. Hernan and Ms. Boylan.
you have a compound inequality. All right, so our category is compound inequalities, and that is cut into two distinct, different types. You have first your intersections. Now remember, this is a type of compound inequality. So you got compound, inequalities. Notice I abbreviated compound inequalities. And you have intersection. An intersection is a compound inequality that uses the word and. The second inequality we're going to talk about, compound, is a union. And a union will use the word or. Alright, so let me explain this to you. And means you must be able to follow two rules. Okay? Or means you can pick one or the other. Just like the word or means. So, you can have French fries or mashed potatoes. Either one of them is the right answer. Okay? You can have French fries and mashed potatoes. That means in order for you to do it, you have to have both. Okay? So I tell people, if you want the discount, like when you go to a... Excuse me for the... When you have to go to, let's say McDonald's, in order for you to get a Happy Meal, you have to get French fries and a drink. You can't pick or choose. Okay? So that is an intersection. Now, in math, when we're talking about compound inequalities, it's where our answers are in between. Okay, so let's look at the example that we used, the two simple inequalities in 2-3. We had this one, x is greater than negative 2, and we had x is less than 5. Now remember, we always start reading these from the variable. Say we know that x is supposed to be smaller, so we say x is smaller than 5. This one I know, oh, x is bigger than negative 2. When we have an AND problem, we can write it in what they call compact form. Only AND problems can be written in compact form. Well, Mr. Fraser, what's compact form? Well, compact form is this. Notice, the inequality signs went in the same direction. Smallest number, largest number, x in the middle. This is called compact form. So whenever you see a problem like this, it has to be an AND problem. You don't have a choice. It is an AND problem. Okay? Has to be. So now let's look at each individual graph, because I have to combine the answers on a graph. So I'm looking for numbers that are in between it. Okay, so simple enough. I know that this one, negative 2, goes this way. And I know if I graph the other one, which is 5, it goes this way. Well, the problem is when you go to do this answer, you have to combine the two, because that's what AND means, to combine. Which means your answer must be between 5 and negative 2. So again, this is an AND question, an AND graph, and an AND solution. They all must be intersecting, and all AND problems are overlapping. Hopefully you know what overlapping means. They're over top of each other. So that means when they are overlapping, we call this conjunction. Okay, conjunction meaning overlapping. All intersection problems are conjunctions. They're all overlapping because the answer's in between two numbers. Alright? Now, is it possible they try to trick you? Of course it is. Let's say they give you something like this. They go, x is less than negative 2, and, that's what this symbol means, and, x is greater than 5. This one has no answer. Well, that's because in an AND problem, you need them to overlap. And if I do x is less than negative 2, and x is greater than 5, are these overlapping? No. So this is impossible. Does that not mean that they can give it to you? They can give this to you. When you graph it, it won't make any sense, and you'll go, oh, wait a minute, AND problems have to overlap. This one has no answer. Okay? So all intersections are AND problems. All AND problems can be written in compact form. All compact form problems are conjunctions. All conjunctions overlap. All overlapping means you have to be in between. Okay? So when you see this, you have to recognize it's an AND problem, and your graph should look like this in the end. Alright. The second type of problem is a union. And a union means this or that. So for example, I tell people unions like getting married. All of my stuff is now hers, and all of her stuff is now mine. some people say her stuff is hers and my stuff is hers. But it's an or problem, meaning one or the other. All right, so here we go. Let's look at this from an or perspective. Or problems can look a couple of different ways, and this is where you have to be careful. An or problem can be conjunction or disjunction. It could be either or. Notice the word or means it could be both. Not at the same time, because that wouldn't make sense either. You can't be overlapping and not overlapping at the same time. Okay? All right, so here we are. Union. Let's go with x is greater than -4, or x is greater than 5. Well, Mr. Frazier, how did I know this was an or problem? Because all or problems must say or. Okay? So you solve them, then you graph every single time. Now these are already solved. These are solutions. So I can just graph. X being bigger than -4 would look like this. And then x being bigger than 5 would look like this. But when I combine these, you'll notice that -4 will overlap with 5. Because if I'm bigger than -4, then I'm going to include anything bigger than 5. So now your graph only has one answer on it, even though you started with 2 problems, 2 solutions. It only looks like this. Why? Because this solution gets swallowed up by this one. They overlap each other, thus making it a conjunction. All right? Now notice, we started with 2 solutions. We had 2 graphings, but because one graph is inside of the other, I can go ahead and just draw one line. I don't have to put 2 separate circles, just one. And it's conjunction. Why? Because they overlap. All right, so now we look at the next one. Well, here's another one that seems a little goofy. Well, let's say x is less than -4 and x is greater than 5. Okay, so now I have this problem and I go to graph it, and remember it's going to say or. Uh-oh. Well, look at this. Now remember, we used open dots because there is no equal to. But hey, they don't overlap. Well, that means there is 2 separate sets of numbers that can answer this. It could be -8, or my answer could be +10. It can be one answer or the other. Why? Because this is an or problem. I can have multiple answers. It doesn't have to be included in both. It can be this answer or this answer. So when I go to graph it, I'm actually done. Why? Because all right. So I went blank for a little bit there. Sorry. But what I was trying to say is that my answer could be -8, or it could be +10. Okay, so I have 2 possible answers that satisfy that. That's why it's called an or problem, because I can pick which one will work. I'm not stuck with just one answer. Okay. So now that I know that I'm looking for a range of answers or things that could be possible, Now you have to be concerned with, well, Mr. Fraser, what happens when I have a problem with this? Well, when you go to solve a compound inequality, your problem's going to start out a little bit different, but the math is the same. The deal is compound means more than one. So one inequality meant we did one math problem. When I say compound inequality, that means we have more than one, which means we're going to have more than one math problem. Well, how do I do it? OR problems are easy. They're going to give you both problems. The tricky one is AND problems, because they're going to give it to you in a compact form, and you have to separate it. Now, I'm going to show you it's not a really hard separation. But let's say we have 336 is less than or equal to 14m, which is less than or equal to 448. Okay, I know I have an AND problem. Why? Because it has to be between 336 and 448. Okay? It's written in compact form, so that's telling me it is an AND problem. Well, I can't solve it like this. Why? Well, because when you had equal, let's just say we had an equal sign, this would make no sense. We've never seen anything like this. There's a reason. It doesn't exist. Okay? You've never seen a problem like that. But if I cover up one side, I can do this problem. If I cover up this side, I can do this problem. Well, that's what we do here. Compact form means I'm going to split this into two problems. That's going to be one problem. That's going to be the second. So the first problem is 336 is less than or equal to 14m. And the other problem is 14m is less than or equal to 448. So now what do? Well, I divide both sides by 14. And this gives me m is less than or equal to 24, correct? Now remember, you're supposed to be doing the math. And when I divide this by 14, I get m is less than or equal to 32. Now, my problem was written in compact form, so my solution must be written in compact form. And that would be how I write my solution. Graphing my solution, why do I know it has to look like that? Because this is an AND problem. AND problems must look like this, or they're not AND problems. Alright? And obviously this is a conjunction. Why? Because all AND problems are conjunctions. So showing my work would be taking this one and graphing it, and then taking this one and graphing it. I'm not asking you to do all that. You can if you want to keep it straight. But you have to know that your AND problem must look like this. An OR problem looks different. An AND problem must look like this. Okay. Now what was the one rule I didn't have to use for either one of these? I didn't have to flip the inequality. Why? Because the number in front of m was not negative. If this was a negative 14, I would have had to flip these signs. Okay? But it wasn't. So I don't. Alright, and this is how all of this works. Okay? It's a continuation of the same process over and over and over again. Now, I am going to share with you a different type of union problem. I'll go back to the union problem. There is a union problem that looks like this. Oh, we already did it. I'm sorry, I was going to go over this one again. But you can see that one is encompassed in the other, so that is a correct OR problem. Now, let's pretend we had an OR problem where they did overlap big time. Well, let's say we had, and we'll go over here. I apologize. This is another OR problem. Okay, this is the third type of OR problem you might have. Let's say I had x is greater than 2, and I had x is less than 5. Okay? And it's an OR problem. Well, how do I know? Because it'll say OR. All right? So when I graph this, it would be x is greater than 2. And when I graph this one, it would be x is less than 5. So it would be open dot 5, and it's this way. Notice, what possible answers can I have? And I'm hoping you say anything, because they overlap each other and then keep going. So that means when you graph it, all you would graph is this. That means anything. Any number will work, because it's an OR problem and they're overlapping forever. Now, they're not overlapping and going in one direction, they're going in opposite directions and overlapping. This means all numbers could be answers. Anything could be an answer. Okay? So this has infinite answers. This has that many solutions, correct? And an AND problem where they don't overlap has no solution. And that's what we were talking about over here. There's no answer, no solution whatsoever for this. It's something that should not happen. Okay? And that is all of 2-3. Being able to solve an inequality, graph it individually, and then telling me whether they overlap or not, or how to put the final graph. How do you know an OR problem? Because it says the word OR. And an AND problem will be written in compact form, or it'll say the word AND. That's my hint that I'm doing a conjunction. All right. Thank you very much. Have a good night.